Greetings and welcome to the Artifact Electronics channel. In this episode we will be finishing up this Elka Rhapsody 610 string synthesizer. In the previous episode we spent quite a bit of time on this, fixing various problems, and if you haven't seen the previous episode I would highly recommend you do so before watching this one, because things will probably make a whole lot more sense after that. So I found another problem here, and the next problem was that the piano clav sounds would drop out randomly, totally disappear. Manhandling the instrument, tapping on the side would bring the sound back every so often, but once you let go it would just disappear again. So I started looking for that. After poking around for a while, I found the problem in this area over here. Now this in itself is the phaser board, and the problem wasn't the phaser board. It's basically sitting in a board PC mount edge connector. These are pretty old. There are no side tabs on them. They basically, the profile allows, and the boards are cut out so they fit exactly over the profile, not allowing any extensions on either side. And the entire instrument uses these kinds of edge connectors. So after looking around further, I found another one of the edge connectors that looked like this. Now, looks okay, but the problem is, if you compare these two, you will see that the back plastic part is missing. So there is a plastic part that is holding the contacts in place, but there's nothing on the opposite end to make sure that the board makes proper contact with those. And after close examination, I mean, it's not very easy to see, but essentially the plastic part that sat here, identical to the one in the back, had broken off and was gone. So what was happening is the board wasn't making proper contact with this connector, and that's why the sound would disappear and come back, and that's why shaking the instrument sometimes would cause it to make contact, or turning it upside down or on the side. So that was definitely the problem. Now, where is that contact? Where was that connector? And that was on this, which is probably I think it's a filter board. But if we look at it, bend these a little bit out of the way, as you can see, it was sitting right over here, and so that part of the circuit board wasn't making a correct contact. The contact being on the back, of course, and that's why the problem existed. Now these are not very common edge connectors. But after searching through my parts box again, I found an edge connector that looked like it could be adapted. Now this edge connector originally looked like this, which is more common with the edge tabs to mount it on board and everything. But again, because of the profile, of the cutout profile, there was no way that would fit, the board would fit over that. And second of all, that I needed a 7-pin connector, a very commonly used number, and the one I had was a 10-pin, so I cut off the ends of it. And another fortunate part was this does have contacts on both sides, but every pair is cross-connected. So what you end up with on the bottom is a single set of pins per pair that are centered on the connector, which matched the contact or the pin profile of the old pin exactly. So that thing soldered right into place, and it does have a second set of pins over here, but they're cross-connected, so there's no new signals on it. And if we look at the board, it's a single-sided board with no contacts over there. So all those contacts will do is hold this board nicely in place, and make the disappearance of the clav piano not happen again. So with that done, I plug things back in, and everything was back to normal. The piano and clav played, and another issue was taken care of. The next issue that needed some attention was that now that the instrument was coming back together and was becoming playable, I did notice that there were a lot of low volume stuck notes. So what would happen is you'd play a note, it would decay, but it wouldn't decay to zero. And after playing many notes, you would essentially have a cacophony of sound in the background of several notes just sounding faintly, but they wouldn't shut off all the way. The problem was different from key to key, and it was more severe on some, i.e. they would get stuck at a higher volume, versus other boards in which they would get stuck at a much lower volume. So I listened to it with headphones, and it was inconsistent across everywhere. But the first thing we need to do is kind of theorize on or localize where the problem could be. And the best way to do that was, my guess was, that the problem lies in these boards, which are basically taking the corresponding frequency for the key that they are tied to, and when the key goes down and gates the board, they apply the envelope to the sounds coming in, to all four instruments, and send them out the common output. So if a note stays on, then most likely it is happening in these boards because whatever is supposed to shut down isn't shutting down all the way. And now, to verify that I was right, I basically found one key over here. You see I have these two boards removed and put down here. And the key corresponding to this connector, the note was getting stuck pretty loudly. So you played it, it would decay for a while, and then it would just drone. The key next to it was just fine. I mean, you could faintly hear it in the background, but it was much less severe than this one. So the way to isolate this is I swapped the boards. I removed these two boards and swapped their position. And then when I tried it on, the problem traveled with the board from here to here. So now this key worked correctly, but this one would sustain indefinitely. That is good news because it pretty clearly isolates the problem to be on these cards, even though there's a lot of them. But on the other hand, if I can find the problem on one of the boards, it is most likely that the same problem exists on all of the other boards. And to further investigate that, let us have a look at the schematics. So here's a schematic for the boards in question. I keep changing their name, but I think the proper name to use for them would be the sound shaping board, that each key activates and gates on and off and creates one or more of the instrument's shaped sound to appear on the common bus. Apologize for the bad quality of the schematics, but they were originally printed on colored background, and that doesn't when I copied them and zoomed in on them a little bit, it didn't help things too much. But basically, this part is where, so this is as far as I know, there's a KS signal coming in that I think that means keyboard strings. There is an LS signal coming in that means a length of strings, and I think that refers to the decay. And then there's an S output, which is a string output that goes to the common bus. Nothing overly complicated here. I went in. First, of course, there is one electrolytic in this particular part of the circuit over here, which is this guy here. And I checked them in circuit, and the ESR meter said they're just fine. I checked, the other capacitors, which are non-electrolytic, and they measured Two of them measured fine in circuit, and the third one I removed, measured out of circuit just for capacitance, and they were fine too. For good measure, I measured all of the resistors. Funny thing here is it shows a resistor here, but that's not really true over here. The output of the diode goes directly to the edge connector. So there's one difference. But probing this sound with a small, hooking this up directly to the amplifier showed that the problem, in fact, was here. And so with really nothing else left to suspect, it was the transistor. The transistor checked good both in circuit, and I took it out, and it checked good out of circuit too. Since I had the opportunity, and these transistors are BC206s, I think, which are kind of hard to replace. I looked at the specs, and it turns out that you can use a 2N3904 NPN transistor, cheap and readily available. Just for grins, I soldered the 3904 into place to see if it still worked. It worked exactly the same way the other cards worked, but the problem was still there, so it wasn't the transistor. I put the transistor back again, the original transistor, and just stared at the board for a while. And one of the things I learned is, if you don't have anything else to blame the electrolytic capacitors. So that, and even though this is completely unrelated, but if you look at the board, the capacitor in question over here has a big red dot on it. I wonder what that means. Is it like, were they trying to tell us this part will fail, it will test good, but it will fail? I don't know, but I took it out of circuit, and I tested it, and it was still good, both capacitance and the ESR. But I went ahead and replaced it on some of the boards, and that fixed the problem. So the thing had, I can't say it was leaky, because if it was leaky, then we would have too fast of a decay. But somehow it was getting parasitically charged, or charging itself parasitically, I don't know how, so as not to let the envelope drop to zero. I won't spend any more time on trying to figure out what the exact defect was. I'm sure there's people better qualified and have better knowledge of capacitor physics, but needless to say, even though the test instrument said it was good, taking into account the age of it and replacing it was what fixed the problem. Now, there's a lot of these capacitors, and not only that, there's another 3 electrolytics on this board, which are probably suffering from the same fate that this one is suffering from. And I started it all with good intentions. I got a bag full of capacitors. Just for all of the voice boards, or what did I call them? The sound shaping boards. You would need 4 times 61, 244 capacitors, which I have, but that would take a really, really long time. And since I've already spent a whole lot of time on this video, I figured, okay, let's do this the short way. And the short way was to basically test every key, and every key that had that got stuck at a noticeable volume, I went in and I replaced this one particular capacitor. That got the whole keyboard back to being even more playable than before. There is still this carpet of sound in the back, very low volume, but other notes getting stuck at no lower volumes. So in the real near future, I will need to go in and replace all of the capacitors on all of the boards. But for now, I've gotten to a point where it is playable, and with that done, let's see if there's anything else that needs to be taken care of here. Since we're already inside the instrument, I thought I'd show you the quality control sticker that is still inside unscathed, and that pretty much tells us that it was tested twice, approved by nobody, on the date of the 27th of May in 1975. And program number, I don't know what that means. But there you have it. This thing is officially, as of today, 42 years and 2 months old. Then came the time to clean intermittent contact closures on the keyboard. I tried isopropyl rubbing alcohol, I tried acetone, I tried contact cleaner. The corrosion is pretty deep on these. I got things cleaned up to a point where the intermittent keys are no longer intermittent, but I suspect that should be a problem that will probably return. In order to do this right, the contact, the bus bars need to be removed, both of them, one here and one hidden behind. I think they'll just slide out of the plastic bracket here, and using an eraser or whatever toxic or non-toxic chemicals I can find, clean that up. And when the bus bars are removed, I'll gain better access to the springs and can probably clean those up better too. But we're going to leave it at that for today. Now, when working with these and sticking cotton swabs in here to clean things, you need to be very careful not to bend or break the contact springs over here, because the contact springs themselves are a bit hard to replace. Now, I had an idea about replacement, which I haven't tried yet because it hasn't been necessary, but here is what I would use if it came to that, and that is a set of guitar strings. They are nickel wound, and I bought one set of them for a couple of dollars, and the biggest gauge that was in there was a 42 gauge. And they look like this. It's about the same diameter as the springs that are currently in there, but and this is probably hard to see, but the springs are very flexible, and these guitar strings are not nearly as flexible. So I'm not exactly sure how that would work, but since everything is bracketed and has guide channels and everything, it will probably work. The only thing that remains to be found out if it does affect the key action significantly, in which case this is not an option, but the next time I need to replace a key spring in this kind of a keyboard, I will most certainly give these guys a try. Now, one thing I need to add is most of the keyboards I've seen of the early era, the American-made keyboards, all used the Pratt Reed keyboards, which were used all over the place. But those were need a lot of maintenance. The bushings go bad, the keys go out of alignment, the contact wires get bent. And it's usually not very easy to get everything really straightened out. This thing's over 40 years old, and except for the corrosion problems over here, everything else is still aligned, everything works. To give you an idea, part of the surface of the keys, there's very little difference in key heights. This keyboard was designed a lot better than most other keyboards I've seen, and that's the only reason this thing still works. If this had a Pratt Reed keyboard, we probably would have had a really lengthy adjustment part of this video, trying to clean the contacts and getting it, leveling the key bed and getting everything back together again. But so much for the key contacts. Another thing I noticed a little while ago was there's a piece of foil tape underneath the cancels section, and let's have a look and see what the foil tape is hiding. And all right, so it's an Elka Rhapsody, and obviously somebody didn't want the didn't want that to show up on a picture or a video or whatever, especially since the back of the instrument says Elka in very large letters, and that doesn't look like it was covered up, but there you go. Now this is restored to its former glory, and it's probably time to put everything together, scare up some slider covers, and give it one final test. She's all put back together, and I refastened the slider carrier board, and then went through my box of slider buttons. These are the only ones I could find. They're kind of retro looking. I think they fit the instrument. If I find anything better, I'll make sure to let you know, but this is what we have right now. So to play it, I mean, it's kind of, to play it dry without any effects, sounds a bit dull, but listen for yourself. It needs reverb, or at least a phase shifter. So I brought in the Boss phase shifter, model number PH3. It's a digital phase shifter with a DSP inside, but I think it'll do the job to bring back that 70s sound. And for comparison, now, you may even hear it on the video, there's still stuck notes. So I'm going to have to go in and replace all of those capacitors. I will spare you that on video. It's just pulling boards, desoldering, and replacing capacitors, and I'll do that at some other time. But I think we're done with this for now. I think it came out well. I hope this will help you along if you ever get something similar to it on your bench and try to get it working again. The very last thing to look at is that I think I mentioned earlier on that it came with its own form-fitted case, which also needed some work. So let's have one final look at that, and then we'll be done. Here's the case it came in. It was a bit dirty. Some efforts had been made to clean it up. The aluminum frame was bent out of shape in several places, making it difficult to close, but since it's aluminum, it was relatively easy to bend it back into shape by hand, so at least it would close. It's nowhere near perfect. Especially here, you can see there's a big gap between them, but I'm not going to deal with that right now. I'm not planning on doing any heavy traveling with this. The plastic case was cracked in the corners, several corners, and I straightened it out as much as I could and used fiberglass matting and car dent filler, automotive dent filler, to glue it into place, and that seemed to do the job. And it can barely be seen from the outside. The hardware was all present and accounted for, but it was haphazardly hanging from the sides because whatever the screws were screwing into had been worn out long ago. There's also 3 hinges in the back. I replaced that wood on the inside and screwed all the hardware back in securely, and that works now. The inside of it was covered in red velvet, in red felt, not velvet. But it hadn't aged gracefully. It was musty, it was dirty, and it was torn. So I reworked the felt on the inside, and this is what it looks like now. I had to remove all of the old felt, of course, to be able to do the plastic repair and to add reinforcement or new wood for the hardware to screw into. The felt replacement wasn't half bad because the glue in it had dried so much I could essentially almost effortlessly pull off all of the old pieces of felt, and there's some soft foam underneath. Use the old pieces, which were somewhat torn up but salvageable, as a template to cut out new pieces of felt, and using a hot glue gun, gluing it all back into place. What was missing was it has these two end pillows, because the case is slightly wider than the instrument, to keep it from sliding back and forth. But I just used some leftover foam I had and the remains of the felt to make these two pillows that slide into the ends and hold the instrument securely in place. I think for any self-respecting Elka, I wouldn't expect any other travel accommodations than deluxe accommodations like this. But as I said before, I don't intend on doing a whole lot of traveling with this. But it's nice to have a case for it. So if it gets stored away, it'll have a secure place to be stored in. Well, we are finally at the end. I hope you enjoyed this. Well, I guess if you're still watching, then you must have derived some enjoyment out of it. In order not to miss any of our future exciting episodes, why don't you go ahead and subscribe and maybe even click the like button on this. And we'll have lots more interesting repair and instructional videos for you to come in the future. Ciao!